in today's video, we're going to talk about Beer's law. Beer's law is describing the absorption of the photons or of the light by things that's in the way of the photon. So what we're going to do is we're going to go over really quickly how this might work. So first we're going to put the photometer in H3 and make sure the detector is lined up to the beam path, and we're going to turn on the laser. And we're going to adjust the laser such that or the photometer such that the beam is focused onto the detector. So this is something you would learn in previous experiment. So there's one trick on doing the experiment. You want to use the lid of the box to prop up the baseboard. So if you look under the baseboard, there's a bunch of rubber feet. And what we want to do is we prop up the baseboard on the top of the lid near the bottom of your desk. So that way you have some height. So you have some space available above the bottom of the baseboard. There's a gap. And then that way when you put your cuvettes in, the cuvette sits nicely inside the slot A of the baseboard, and also the bottom of the cuvette will be on the bottom of the lid. So that way whereas if you don't have the lid, then your cuvette might be free to move too much. But where if you prop up the baseboard, the cuvette, it's more stable this way. And you want to avoid the rubber feet touching the edge of the lid. So pretty much you could see I just choose a spot where the rubber feet is not on the edge of the lid. So that gives you a more leveled baseboard to do the experiment. So right now we're getting about 3.4, 3.6, 3.46, 3.45 intensity for the full strength of the laser. And your laser number will be different. Now, what we're going to do is we're going to put different things in front of the photo detector in order to weaken its intensity. So if you put an empty cuvette in slot A, or right here, now you could see the intensity drop down to about 2.8 milliwatts. So right now the detector has the milliwatt scale. Now what we're interested in is, even though you have some light losses, but a lot of those light losses come from the reflection of the faces. So we need to sort of negate that that contribution. So what we're going to do is we're going to put some water in here. And the choice of the chemical we're going to use for absorption experiment is copper sulfate solution. So this is 1/2 molar. But you could use other things of interest, say like, for example, Coca-Cola or some other drinks or some other colored liquid to do this experiment as well. But the kit is provided with a bottle of 1/2 molar copper sulfate. So what we're going to do is the kit also comes with a pipette. So for this experiment, you also need a little cup of water. So if you have a purified water is great. If you have tap water, that's also fine. But if you live in a region where you have very hard water, then you might consider just go to the supermarket and buy yourself a distilled water, a bottle of distilled water or a purified water. Mineral water is no good for this experiment because it's got minerals in it. So what we do is on the pipette, there's graduations. You could see the graduation right here. See where my thumb is? It's about 1 milliliter. We don't really care about the graduation so much, and we're not going to trust the graduation. But what we do want is we do want to use that as a mark to measure out volumetric different ratios of the stock half a molar solution. So first what we're going to do is we're just going to put some water in it. So we're going to suck up the water until it's at that graduation mark. So that's about 1 milliliter of water. Again, we don't necessarily trust the graduation that much, but it's just a reference line that we need. So you could see I'm sucking it up to about the same level every time. So I want enough water to cover about to cover up the beam path. So now I'm going to put my cap back. And then if I drop in my cuvette here, so you could see as I take it out, the laser goes back to the air path. And then now if I put some water, the light is a little bit more diminished. All right, so now what we're going to do is we're going to take and then we're going to put this aside. And then now we're going to take our bottle of copper sulfate and open it up. It's a little bit might be hard to open on the first one because there's a seal, so you have to break that seal as you twist it. And then your bottle may or may not have the nozzle punctured already. So if it's not punctured, that's fine. Just take a sharp needle and puncture it. So you could break that hole open. In this case, has already comes with the needle open. So we're going to take another empty cuvette, and then what we're going to do is we're going to put some of these in there. So it would be about the same height. You could get rid of this ring. This ring is not useful anymore. So we're going to fill it up. Just be gentle on your squeeze. You don't want to squeeze it so hard that the nozzle comes out. So eventually it'll get there. All right, so I want to have about the same level. So this is about what I had before, is about 3 milliliter. And this step is not too critical, meaning the volume is not super critical to be accurate. So now I have a bottle that's 3 milliliter or thereabout of 0.5 molar copper sulfate. So if I put that one in, then you could see the intensity drop quite a bit, right? So now I'm down to 0.09, very most small amount of light passed through that. And your job is to pretty much plot out the concentration versus intensity, right? And based on that, then you could use a Beer's law equation, which is right behind here, right here, the Beer's law equation, to determine the cross-section absorption of a copper ions, right? So that's one of your exercise. And now if we want to prepare other concentration, what we could do is we could take this guy out. Say for example we want half of this, right, which is this is half a molar. So if we want a quarter of a molar or 0.25 molar, then what we'll do is we'll take yet another cuvette, and then you'll say, hey, that's just half and half of the stock solution in water, and you'll be correct. So we're going to take the pipette, and then we're going to take we're going to use our reference line again, and then we're going to use about 1 milliliter. So let me do that again. And this one you want to be slightly more careful about where you, there you go. So that's about 1 milliliter of water. I'm going to put it right in here. And if you haven't used a pipette in your life before, that's fine. Just practice a few times before you put it in the real deal. So that way you won't spill the liquid everywhere on the circuit board. And then we're going to take our solution from the stock, which we pour in, and then we're going to take about 1 milliliter out of that, following the same mark as well, right there. And then we're going to go in there. Then you can see, because I added equal parts of the stock solution and equal parts of water, now I have a solution that's half and half, so it's about it should be exactly 1/4 of a molar, and then you could see the number is different. And then there's yet another empty cuvette, and then you can mix in another ratio that you feel like maybe 1 part water, 2 parts the neat solution, or 2 part water, 1 part of neat solution. Depends on what you choose to use. And then you could also empty out the solution and make other concentration of your wish. Now, to dispose of this, in most states in the United States, copper sulfate could be legally dumped into the toilet or in the drain. But before you do so, you might want to consult your local city or state law just to make sure it's okay to do so. And then the other thing that's very important, don't drink this stuff. It's mildly toxic, and do not ingest. And then if you get onto your skin, it's not a very big deal, but just wash your skin. It's not very corrosive. But just keep it safe, right? So dispose of it. Just talk to your professor or consult with your local legal law to see how you dispose of it. But in most places that I know of, you could just safely dump this into the drain without any problems. And then what you don't want to be doing is you don't want to be dumping this back into the bottle, because unless it's a full strength one, right? If you full strength one, this is the same concentration as this. But if you put any sort of water back into the bottle, then you are diluting the bottle, and then you will have an unknown concentration next time you use this bottle. So that's it for this experiment for the Beer's Law, and I'll see you on the next one. Bye.